Okay, Wildcat, so we're looking at 4. Logging on. Solving logarithmic equations. Warm up. Use the properties of logarithm to rewrite each expression. One, log base 3 of 8 times x to the 4th can be rewritten as log base 3 of 8 plus log base 3 of x to the 4th. 2. Log base 2 of 5y to the 6th divided by x to the 4th can be written as log base 2 of 5y to the 6th minus log base 2 of x to the 4th. 3. 2 times log of x minus 2 log of y can be written as log of x squared minus log of y squared, which can be written as log of x squared divided by y squared. Go ahead and finish up the warm-up. Alright, let's take a look at the next page. Sound off. A decimal is a unit used to measure the loudness of sound. The formula for the loudness of sound is given by dB equals 10 times log parentheses L divided by L naught. Where dB is the decimal level, the quantity L naught is the intensity of the threshold sound. A sound that can barely be perceived. The quantity L is the number of times more intense a sound is than the threshold sound. Excuse me. 1. The sound in a quiet library is about 1,000 times as intense as the threshold sound, or L equals 1,000 L naught. Calculate the decimal level of a quiet library. The decimal level equals 10 times log of 1,000 L naught divided by L naught. Now, anything divided by itself is 1, so this becomes 1. So we just need to put in 10 times log of 1,000 in decimals. So let's go ahead and do that now. So log base 10. Oh, almost forgot. 10 times log base 10 of 1,000 equals 30. Okay, so a quiet library has a decimal level of 30. Two, the sound of traffic on a city street is calculated by 500 million times as intense as the threshold sound. Calculate the decimal level for city traffic. Decimal level equals 10 times log of 500 million L naught divided by L naught. Now again, anything divided by itself is 1, so this divides and becomes 1. So we just need to put this in decimals. So 10 Let's go ahead and round that to a whole number, so let's round that to 87. So city traffic has a decimal level of 87. Go ahead and mark out 3. And let's take a look at the next page. 4.1. Solving logarithmic equations. While most medications have guidelines for dosage amounts, doctors must also determine the amount of time a medication will remain in a patient's body before it metabolizes. When they write prescriptions, the amount of medicine remaining in a patient's body can be predicted by the formula. Where T is time in hours since the medicine was administered, C is the current amount of medicine remaining in the patient's body in milligrams, A is the original dose of the medicine in milligrams, and R is the rate which the medicine is metabolized. 1. A patient is given 10 milligrams of medicine which is metabolized at the rate of 20% per hour. How long will it take for 2 milligrams of the medicine to metabolize? So we need to plug the numbers into the equation, which we've done here, and let's go ahead and use Desmos. So, divide equals 1. So it will take 1 hour for 8 milligrams of medicine to remain in the patient's body. All right, you go and finish up number 1. All right, let's take a look at the next page. Suppose you know that 4 hours after administering a 12 milligram dose of medicine, 9 milligrams remain in the patient's body. How can you determine the rate at which the medicine metabolizes? You can solve for an unknown in a logarithmic equation by using the properties of equality and by rewriting the logarithmic equation as an exponential equation to isolate the variable. Go ahead and look over the worked example. 2. 6 hours after administering a 20 milligram dose of medicine, 5 milligrams remain in the patient's body. At what rate is the medicine metabolized? So we need to graph y equals 6 and y equals this and find the point of intersection. So let's go ahead and do that now. So y equals 6 and y equals 6. Now instead of r, we're going to use x. And then we just need the point of intersection, which is right here. So that would be 0.21, which is 21%. Which we can write as 21%. So the medicine is leaving the body at a rate of 21% per hour. Three, a patient is undergoing an 8-hour surgery if 4 milligrams of medicine must remain in the patient's body at the end of the surgery, and the medicine metabolizes at a rate of 15% per hour. How much medicine must be administered at the start of the surgery? Okay, so we need to graph y equals 8. And we're going to change this to 4 divided by x. And 1 minus 0.15. Zoom out. Click the point of intersection. Let's round that to a whole number, so 15. So A equals 15. So the patient should receive 15 milligrams of medicine before the 8-hour surgery. All right, let's take a look at the next page. Go ahead and mark out this page. Go ahead and mark out this page. Go ahead and mark out number 5. The student works 6A and 6B. Go ahead and mark out this page. The student works 2A, 2B, and 2C. Go ahead and mark out 3. The student works 4. And then go ahead and mark out 5. The student works 6A, 6B, 6C, and 6D. Go ahead and mark out this page. Go 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 and mark out this page. Then go and finish up your notes, start working on the assignment, and have a wonderful Wildcat day.